Hi everybody, today we're going to talk about systems of linear equations in two variables. It might be a little bit long, I have a lot to cover this time, so if you need to stop me and come back later, that's perfectly okay. Let's start by talking about the types of systems we can have and the kinds of solutions we can get. So first we could have something that's consistent, meaning we have two lines and they're going to cross at a point. We could have inconsistent, which means they're not going to cross at all, and that means the lines are parallel. Or we could have an identity, and that says they cross at all points. When I say that they cross at all points, it means all the points on one line are the same as all the points on the other line, and essentially we just have the same line written twice. As we look at these lines, we're going to have three different ways that we can solve our system of linear equations. So the first thing I'll go through is graphing. Then we'll talk about substitution, and then finally we'll have the addition or elimination method. So as we're going, and we're kind of hoping to get these consistent equations, we want to remember that when lines intersect, they do so at a singular point, and those points have two coordinates, x and y, so you want to answer it with a point, so make sure you're using the right notation and that you give both coordinates when you put that into your homework or quiz or whatever you're doing. So let's try this first. We're going to graph y equals 2x minus 8, and we're going to graph y is negative 3x plus 2. We'll start by kind of extending the y-axis here because I had negative 6, negative 7. Let's go down here and say this is negative 8, my y-intercept. I'm going to go up 1, 2, and over 1 using that positive 2 slope. And because I'm graphing by hand, I'm probably going to put quite a few points on there because I know that my drawing capabilities are not really strong. So if I can just count up 2 and over 1 over and over again, I think I'm going to get a better line. Then I'll do my best to kind of connect the dots. The other one says I'm going to start at positive 2 and I'm going to go down 1, 2, 3 and over 1, and then down 1, 2, 3 and over 1. And luckily we see this point right here that's in common to both lines. And again, my drawing's really bad, but hopefully we can see that this has an x coordinate of 2 and a y coordinate of negative 4. So let's write that down to negative 4. Now for me, because I'm not a good drawer, I would probably put this into technology, so let me show you what that looks like too. So I'm in Desmos, I'm typing y is equal to 2x minus 8. Then I'm typing y is equal to negative 3x plus 2. You can probably see this point of intersection and you can click on it so I can see 2, negative 4. It just looks better when I have technology do it. I would never try to actually graph anything by hand. I would rely on technology, but it does verify the answer and I really like that. So let's give that another try. This time we have 3x plus y is 6, and we have 2x minus y is 4. So I like to graph from slope-intercept form. So I would first write this as y is negative 3x plus 6. Then I would write negative y is negative 2x plus 4, which gives me y is 2x minus 4. So these are the two lines I'm going to graph. So let's start with the negative 3x plus 6. I start at 6. I'm going to go down 1, 2, 3 over 1, and I'm going to do it a few times. 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1. So here's my line, pretty steep with a negative 3. Pretend that's straight. Let's go to 2x minus 4. Slope of 2 says up 2 over 1, then up 2 over 1, up 2 over 1. I'm going to try to connect those points. Really what's essential is that I see this point, which is 2, 0. And here I'm going to graph the lines as they were originally given. So 3x plus y is 6 and 2x minus y is 4. I can see my point of intersection, which is on the x-axis at 2, 0. So we got the same thing, just did it a different way. So let's move to our second method, which is called the substitution method. And really, we just plug one thing in for the other. So I have x plus y is 7 and y is 5. So wherever I see y, instead of leaving y, I'm going to plug in the value of 5. So this says x plus 5 is 7, which says x is 2. So a really nice quick problem. Write the answer as a point. So the x is 2, the y is 5. This is my solution. Let's make that a little bigger. Now I have x plus y is 16 and y is equal to 3x. So just like last time, wherever I see y, instead of writing y, I'm going to write 3x. I have x plus 3x is 16. X and 3x is 4x. I divide by 4, and I get x is 4. So I know my x value. To get the y value, I do 3 times 4, so I'm using this y equals 3x to get my y value, and that says 12. My answer is 412. A little bit bigger. 4x plus 2y is 8, y is 3x plus 1. So I have 4x plus 2 times, instead of y, I write 3x plus 1 is 8. So I have 4x, and I'm distributing 2 times 3 is 6x. 2 times 1 gives me 2. Still 8 on the right, so 4x plus 6x gives me 10x, plus 2 is 8. I'm going to subtract 2, so 10x is equal to 6, and then divide by 10. So x is 6 over 10. Let's simplify that to 3 over 5. So I have my x value. Now I need to find my y value, so I'm going to plug that back in. So y is equal to 3 times 3 over 5 plus 1. 3 times 3 is 9 over 5 plus 1. We could write 1 as 5 over 5, so 9 plus 5 is 14 over 5. Here's my y. So let's write this answer as a point, 3 over 5, and then 14 over 5. So our third method is called the addition method. Sometimes people call it the elimination method. It means the same thing. Essentially, you're doing exactly what it says, is we're going to add together the two lines. And what we hope for is that we'll go from 2 equations with 2 unknowns down to 1 equation with 1 unknown. The first one works perfectly. If I add 2x plus y equals 7 to x minus y is 5, 2x plus x is 3x, y minus y cancels, 7 plus 5 is 12. So we eliminated one of the variables. I can divide by 3, which says x is equal to 4. So once I have the 4, I just plug it back in. So let's say I do 2 times 4 plus y is 7. This is 8 plus y is 7, so y is negative 1. And you pick which line you want to plug the 4 into, the first or second, it doesn't matter. So here's my 4, negative 1 answer. Addition is really helpful, but sometimes you're going to have to do a little bit more work. If I look at this, x plus 4y is 13 and 8x minus y is 38. And if I added those together, x plus 8x is 9x, 4y minus y would be 3y, and then 38 and 13 would be 51, and nothing eliminated. So our goal is, let's make one of the variables go away. So what we need is an additive inverse. That's just a fancy way of saying we need the same number but opposite sign. So what I'm going to concentrate on here is the y's. I have a positive, I have a negative. But I really need a negative 4 to make the positive 4 go away. So what I'm going to do is I'm going to take this second line and I'm going to multiply it by 4. That's going to create a negative 4 for the y. So I'll have x plus 4y is 13. That doesn't change. Then 4 times 8 is 32x. 4 times negative y is negative 4y. And then 4 times 38 is 152. Now when I add these together, this is 1x and 32x is 33x. The y's have canceled, and I get 165. When I divide by 33, I get x is equal to 5. So now we want to plug that back in. I'm just going to the first line. You could use whichever one. So 5 plus 4y is 13. When I subtract 5, that says 4y is 8. Divide by 4, you get 2. So here's my 5, 2. So let's try another one. This one says 9x plus 2y is 10. I have 5x plus 7y is negative 18. So nothing really matches right now. So our first thing is to decide, do I want to get rid of x? Do I want to get rid of y? And just because I've gotten rid of y so often, let's get rid of x this time. So I look at 9, I look at 5, and I think, okay, what number are they both a factor of? And I'm kind of looking for the least common multiple. So 9 and 5, I just think, well, if I multiply them, I would get 45. So I want to make the coefficient of x 45. I want to make the coefficient of x a negative 45. So I'll start by multiplying by 5. 5 times 9x is 45x. 5 times 2y is 10y. 5 times 10 is 50. I'm going to multiply the second line by a negative 9. So that way I get my 45, but it's negative. So negative 9 times 5, negative 45x. Negative 9 times 7 is a negative 63y. And then negative 18 times negative 9 is now a positive 162. Add those together. The 45's cancel. 10 and negative 63 is negative 53y. And then 50 and 162 is 212. So divide by negative 53. That comes out to a negative 4. So here's my y value. I take this and I plug it back in. So I have 9x plus 2 times negative 4 is 10. 9x minus 8 is 10. Says 9x is 18. Divide by 9, you get 2. So my answer is 2, negative 4. So hopefully we're starting to get the hang of it. The next one says 4x plus 8y is 12 and 3x plus 6y is 14. Let's get rid of x again. I see a 4, I see a 3, I think 4 times 3 is 12, so let's make both coefficients of x 12, one positive, one negative. First line I multiply by 3. There's 12x plus 24y is 36. Then let's multiply the second line by negative 4. I get negative 4 times 3x is negative 12x. Negative 4 times 6y is minus 24y. And then negative 4 times 14 is a negative 56. So add that together. 12x minus 12x cancels. 24y minus 24y also cancels. So the left side is 0. The right side, 36 minus 56 is negative 20. Now, this should not make sense. You should say, like, that doesn't make sense. 0 can't be negative 20, and it's not. So what this means is we've come along our first inconsistent system. These two lines are parallel, so there is no solution to this set of equations. So let's write that out. A system of equations is inconsistent if it does not have a solution. This occurs when lines are parallel and therefore never intersect. Let's try that again with the addition method. This time I have 12x minus 9y is 6, and I have 8x minus 6y is 4. Let's this time grab the y, because we've done the x a few times, and let's talk about this like least common multiple. So you could do 9 times 6 is 54, but that's kind of a big number. So hopefully you see instead that with 9 and 6, I could use the number 18. 9 goes into 18. 6 goes into 18 as well. Sometimes it helps to think like 9 is 3 times 3, 6 is 3 times 2. So when I'm looking for factors, this common factor counts once, then I multiply by the other 3, I multiply by this 2, 3 times 3 times 2 is 18. So what do I want to do? Let's multiply the first line by 2, that way 2 times 9 is 18, and then the second line I'm multiplying by negative 3. I want one to be positive, one to be negative. So 12 times 2 gives me 24x. 2 times 9, I have 18y. 2 times 6 is 12. Negative 3 times 8 is negative 24x. Negative 3 times 6 is positive 18y. And negative 3 times 4 is negative 12. This time I start adding together and I'm noticing everything cancels. The x's cancel, the y's cancel, that's a 0. The 12 and the negative 12 also gives me 0. So this is kind of like what we did last time, but a little different. Last time we had 0 is negative 20. That doesn't make sense. This time we have 0 equals 0, which makes sense. So this says these are the same lines. 12x minus 9y is 6 and 8x minus 6y is 4 overlap each other. They're the same line. So what we want to say here is this is an identity. With identities, there are infinitely many solutions. So what I'm going to do is say 12x minus 9y is 6, and I'm going to write this in slope-intercept form. So negative 9y is negative 12x plus 6, divide by negative 9. So y, negative over negative is positive. 12 over 9 I can write as 4/3 of x. 6 over negative 9 makes it negative. This is 2/3. So any point on this line, y equals 4/3 of x minus 2/3, is going to be on both of these lines. So my solution set is the set of all points x, y, where y is equal to 4/3 of x minus 2/3. So I just want to give the whole line back and say, hey, I'm going to have all these points in common. So let's write that out. So it's clear in your notes. When you have the same line in two different presentations, you'll get infinitely many solutions to the set of equations. The solutions can be expressed as a set of all points xy such that y is mx plus b, or you could write the set of all xy such that ax plus by is c. So you just want to kind of follow that up with how the line is written to show we know there's a lot of points. So let's try some applications to see how this is used. I did take these figures a little while ago, so they could have increased, decreased a little bit, but it gives you a nice basis for how we use systems. So let's say Lyft XL charges a base fare plus a cost per mile. The amount definitely varies by city. So in San Diego, a customer pays $14.48 for an 8-mile trip and will pay $17.60 for a 10-mile trip. So let's figure out what the base fare is and the cost per mile in San Diego. So what do I think about here? Well, I think about like the cost is equal to the amount per mile plus some base fare. So I see one cost, $14.48, is equal to some base price that I don't know, so I'm just going to call that M, and that's for 8 miles, so let's put in 8, plus the base fee that I don't know. I also know $17.60 is equal to that same M, the cost per mile, but this time this was a 10-mile trip, and we have that same base fare. Now the easiest thing to do here is the addition method, and really instead of adding, I'm going to subtract, because what will happen is these b's will cancel out, and that'll be super helpful. So I subtracted $14.48 and $17.60, and I got negative 3.12. If I do 8 minus 10, that gives me a negative 2m. I like the number first, so I rewrote it, and the b canceled out. So let's divide by negative 2, and that says m is equal to 1.56, so we're paying $1.56 per mile. Now let's find the base fare. So I'm going to go back to the first equation, 14.48. Now we know that's 1.56 times 8 plus whatever the base fee is. So that says 14.48 is equal to 12.48 plus b. I subtract 12.48 and it says b is equal to 2. So my base fare is 2. My cost per mile is 1.56, and we use the addition method. Let's look at streaming services. So a streaming service has a monthly revenue of $258.4 million. It has 14 million customers that have either basic service for $12 a month or a premium service for $20 a month. So let's figure out how many customers have each type of service. We need to start by putting in variables. So let's say this basic service for $12 a month is X. And then the premium service for $20 a month is Y. So if I add X plus Y together, I have 15. And let's say this is a million. So the number of people that have the $12 a month service plus the number with the $20 a month service totals 15 million altogether. Now everybody that's an X pays $12. So that's 12X. Everybody with the premium pays $20. That's 20Y. And together they get 258.4 million. Since I did addition the last time, let's do substitution this time, and maybe I say y is equal to 15 minus x. So I'll just rewrite it. So here's 12x plus 20 times 15 minus x is 258.4. So leave the 12x, then multiply. 20 times 15 is 300. 20 times negative x is negative 20x. I still have 258.4. I take 12, I subtract 20, that gives me negative 8x, plus 300 is 258.4, and then I subtract 300. So that says negative 8x is equal to negative 41.6, which says x is equal to 5.2. So I have 5.2 million customers that have the basic service. And then for y, remember y is 15 minus x, so minus 5.2, which is 9.8. So this says I have 5.2 million with my basic service, and then 9.8 with the premium. So the last thing we're going to look at is a little bit of cost and revenue and profit. So a vending machine typically costs about $3,000 to $5,000. So let's assume we buy one for $3,800. And we can purchase cans of soda for 25 cents. We're going to start by making a cost function where x is the number of cans of soda purchased. So we're going to say C of x is 0.25x plus 3,800. So here's our cost function. Revenue is how much money do we make. So let's say we sell the cans for 75 cents each, then our revenue is 0.75x. Profit is always the difference between revenue and cost, so P equals R minus C. So our profit is equal to 0.75x minus parentheses 0.25x plus 3,800. So when I subtract my profit is 0.75 minus 25 gives me 50x. Remember to distribute this negative. It goes through both, so this is minus 3,800. So what we want to find here is the break-even point. So break-even is when revenue equals cost. It's also when the profit is 0. So it's finally when I went from losing money to gaining money. The thought is you had to spend money. So we started down here at our 3,800 that we spent, like that was negative, and we have to sell until we finally make enough that we hit 0. That's what we're looking for. So our profit, which we just had, was 0.5x minus 3,800, and we want to set that equal to 0. This is the same as having two functions, the revenue and the cost, setting them equal to each other. So that's why this is kind of thrown into the system of equations, but we'll do it from this perspective. So 0.5x is 3,800. We're going to divide by 0.5, which means x will be 7,600. That's a lot of cans of soda just to break even, just to not even make any money. So I hope this overview of systems of equations was helpful. We will come back later and talk about 3 equations and 3 unknowns. For now, we just did 2 equations and 2 unknowns.